Hey there, welcome back to another Run the Docs session. My name's Andrew, and let's jump into it. So today I actually want to jump into one that I've always been wanting to sort of like learn, which is actually trying to train our own model. And then I met the founders of this company called Unsloth for a little bit, and they were super nice. They seemed like a really cool team, and I've heard great things about their platform. So I think today is the day that we're gonna want to try it. So as always, let's start with the documentation. So if you guys are not familiar with this format, Run the Docs is basically saying what can we learn within like 30 minutes to 60 minutes just reading docs and their technical content. So this one we might see some Jupyter Notebooks and things of that nature. So emphasis on the technical content, and I'm actually just going to set a stopwatch. And then if there's things where like I have to sign up for something or like create an account in another system, sometimes I'll pause the video, but here we're starting that stopwatch. Okay. So Unsloth makes fine-tuning large language models like Llama 3, Mistral, and Gemma 2 times faster using 70% less memory and no degradation. And you know what? Actually, I'm going to be right back. I'm going to get a cup of water real quick. Okay, I am back, and it's only been about a minute. So let's get back to it. So Unsloth makes fine-tuning large language models like Llama, Mistral, and Gemma twice as fast. Docs will guide you through training your own custom models. It covers the essentials of installing and updating Unsloth and creating datasets. So get started. Fine-tuning guide, Unsloth notebooks, all our models. Okay, but let's see why Unsloth. Makes it super easy for you to train models like Llama 3 locally or on platforms such as Google Colab and Kaggle. We streamline the entire training workflow, including model loading, quantizing, training, evaluating, running, saving, and exporting, and integrations with inference engines like Llama, Llama CCP, and Virtual LLM. I'm just guessing it's Virtual LLM. Key reasons to use Unsloth is because of our deep involvement in fixing critical bugs across major models. That's super cool and impressive. After contributing essential fixes that improve accuracy and stability in prompt handling. Our bug fixes include a 2% accuracy boost for Llama 4, connections and identification of uninitialized weights in Gemma 3. And Sloth is highly customizable. For Windows installation, see here. So what is fine-tuning? So I think this is super helpful because I'm personally not a machine learning scientist or things of that nature, so it's like nice to define it. Fine-tuning an LM customizes its behavior, enhances domain knowledge, and optimizes performance for specific tasks. Fine-tuning is the process of updating the actual brains of the language model. By fine-tuning a pre-trained model on a dataset, you can update knowledge, introduce new domain-specific information, customize behavior, personality, or response style, which is really cool, optimize for tasks. Train the LM to predict if a headline impacts, this is example use cases. So here we're basically saying we could cater the model to do specific things, like train the LM to predict if a headline impacts the company positively or negatively, use historical customer interactions for more accurate and custom responses, fine-tune on legal text for contract analysis. You can think of a fine-tuned model as a specialized agent designed to do specific tasks more effectively and efficiently. Unsloth can be installed locally via Linux, Windows, or Kaggle. Oh, there's installing and Unsloth requirements. But I think I'm just going to jump to beginner here. Let's see. Or Unsloth requirements. Tutorials, how to fine-tune and run LMs. I think this is it's hard to figure out what to start, but let's just start here. Works on Linux and Windows, so this is a Mac, so this is definitely not going to work. So what are our options? Fine-tuning guide. Fine-tuning customizes its behavior. We sort of already know what fine-tuning is. With Unsloth, you can fine-tune for free on Colab, Kaggle, or locally. Oh, I like that. I don't know what Colab and Kaggle really are too much, but it sort of sounds like it's not our computer. So, and I've like heard about Kaggle in passing, and then Colab. Let's maybe do Gemma. Okay, so this is a Jupyter Notebook. And then, by the way, I created a new Gmail account just in case we would use something like this. Okay, to run this, press runtime and press run on a free Tesla for Google Colab. To install Unsloth on your own, come over here. Oh, I don't think we can do that. Okay. Okay, so here we're doing installation. Pip install. Library. I'm guessing these are libraries. Unsloth Zoo. From Unsloth. Oh, here we go. This is installing Unsloth. And then this is installing Unsloth here. Okay. So let's run it. Yeah. And this one actually just says runtime, run all. So I think I'm going to do that, but I'm going to try to understand this a little bit more. Fast model supports loading nearly any model now. This includes vision and text models. It'd be sort of cool to know what fast model is, but I also know this is a Jupyter Notebook. Oh, learning ML. Above. So this is like getting all the models here, other popular models. Unsloth will patch your computer, enable twice as fast, free fine-tuning. We now added a LoRa. You know, that's the one thing I saw on their website too, is start for free. I guess I just want to make sure. I'm a little bit nervous that this would be expensive, but all of this says start for free. So this is the one that I'm on? This really looks like it. Yeah, all right. We now add a LoRa adapter, so we only need to update a small amount of parameters. Turn off just for text. Okay, so this is like if it wanted to train on like images, I'm guessing. And this is like a whole new domain for me, so this is like, it might be a bit embarrassing. Oh, that's funny. Opened up the dictionary. Fine-tuning. Fine-tuning layers, should leave this on. Maybe I'll come back to a section here where we can sort of learn about this stuff. Should leave on always. We now use the Gemma 3 format for conversation styles. And they're using like a dataset here. So this just looks like a bunch of data that we're going to like train the model on, I'm guessing, but let me double check. We now use Gemma 3 format for conversation styles. User beginning of sentence, I'm guessing, start of turn, user, hello, end of turn, start of turn, model. Hey there. We use the get chat template function to get the correct chat template. We support Zephyr, CatML, Mistral, Llama, Alpaca, a bunch of models I'm guessing here. We then import get chat template. From the data sets, we load this guy here. So here we're just prepping the data in a GPT style. we get a chat template. Not quite sure what a chat template is. So a couple things we don't know is these parameters, what these mean. And then I'm not quite sure what a chat template is, but I'm guessing it's something to do with how chatbots converse. We now use standardized data formats to try converting data sets to the correct format. Okay, let's see how 100K looks like. That's a model operator. We now have to apply the chat template for Gemma 3 onto the conversations and save it to text. We now have to apply the chat template for Gemma 3 onto the conversations and save it to text. We remove the beginning of sentence token using remove prefix. So we have example conversations, apply chat combo, tokenize equals false, remove POS for combo and combos, dataset.map. See how the chat template did. Start the turn. Now let's use the Hugging Face TRSF trainer. I guess I'm sort of confused where Unsloth comes into play. Okay, maybe we'll just run this one at a time to understand it. Now robot. So we're installing the packages. Okay, so I guess we installed it. Now we'll run fast model. So if you're unfamiliar with Jupyter Notebooks, my understanding is you usually have to do all these steps in order. So it's usually code blocks you execute in a sequence together. It's really used for a lot of research and things of that nature. Patch your computer. Okay, so this is the Unsloth part, I think. So fast model from Unsloth, Gemma 3.4 bit.it. Huh. I wonder if this means you just have lighter weight gemmas that I can use as well. So I am interested in some local models too, but sometimes I notice they take a lot of power. So this is actually pretty interesting. Let's see where we are at time. So we're about at 16 minutes. Okay. And then now we add Laura's. Oh, I guess this isn't done yet. So it looks like Unsloth import fast model. So we're creating both a model and a tokenizer here, I'm guessing. From this is returned both a model and a tokenizer. We now add LoRa adapters, so we only need to update a small amount of parameters. Okay, let's make it happen. I forget honestly what LoRa is. What is LoRa? Wide area network. And slash AI. Is a way to adapt a large machine learning model for specific use cases. Low rank adaptation. Okay. So we now add low rank adaptation adapters. So we're trying to train this for a specific purpose. So we basically now add LoRa alpha. Yeah, I'm still not quite sure because I see fast model, get PFT, and I see LoRa here, like LoRa alpha, LoRa dropout, but I'm not quite sure what that is yet. Okay, and then here we're prepping the data. And then I think I ran this. And I know it's faster if we hit run all, but it's sort of nice to sort of see this going one at a time. Okay, so we're loading the data set. We're defining data set equals loading the data set. Okay. And then we now use standardized data formats to try converting the data set to the correct format for the fine tuning. Okay, so I think we get the, let's see, we standardize data formats. So we import this and we take the data set that's loaded here. What do we do with the chat template? We get the tokenizer. Tokenizer equals get chat template. So we now use Gemma 3D format for conversions. Now we're going to look at a specific row of the data set, which is conversations content. What is the modulus operator in program and how can I use it to calculate the modulus of two numbers? Programming the modulus operator is represented by yada, yada, yada. Okay, so this is just like a row of the data set. We now have to apply the chat template onto the conversations and save it to the text. We remove BOS. We now have to apply the chat template for Gemma onto the conversations. The conversations are in the data set. So here, examples gets passed here and conversations. So data set, okay. So we're taking formatting prompts function here that we defined. And now, so I guess like this new format is text.text. And now we're going to be targeting that same data set and we mutated it to this. Okay, interesting. So now, before, this didn't have like a text field, and then this function basically added the text field. And I'm guessing it took the chat template. Was that it? Add generation prompt. Okay, tokenizer.apply chat template. So tokenizer is here. Yeah, okay. So tokenizer has like a function of apply chat template. Tokenize equals false. Convo is example conversation, so that's the data set. We remove the beginning of the sentence for combo and combos, and we create a new data set. Okay, this is pretty cool. Now we're cooking. Okay, now let's train the model. Let's use the Hugging Face SFT trainer. Okay, let's see what this is. Supervised tune trainer is the most common step in post-training foundational models as one of the most effective. We provide a simple API to train models. So if you have a data set, what is the most common step in post-training models? It'd be nice to know the significance of what SFT is, but this is Hugging Face's doc, so let's just go through here. So let's train this model. Okay, this is pretty cool. So we import TRL. From TRL, we import SF trainer. we define trainer here, we pass it the model, then our model is defined all the way up top here. And I think our model should be, looks like our model to mutate the model. Okay, fast model. And we mutate it again here. And then I'm also not like the biggest Python guy, so if my understanding is in left field, let me know. Tokenizer equals tokenizer train dataset. That's the dataset. Can set up evaluation. Okay, so this is basically the main field we're looking at. I think so it'd be this one. Imperative device train batch equals 2 gradient. Don't know what gradient accumulation does. So all of these parts I'm a little bit lost. I think that's why they're like linking to this, because this is probably all stuff from Hugging Face. And after this, we're going to, well, let me make sure I understand what's going on here. We're going to train the model. So this is the part where it's consuming all the data from the data set, and each row of the data set, it's just looking at text, or like that's what it's emphasizing on. And then, yeah, I think that's my limited understanding here. And then from that, we can also use Unsloth training on completions method to only train the system outputs and ignore the loss of the user's input. Okay. Ooh, I'm super slow. So here, I'm going to train on responses only. Train on responses only. We're using the train on completions method to only train on the system outputs and ignore the loss on the user's inputs. This helps increase accuracy of fine tunes. Okay, so we're like focusing less on the inputs and focusing more on what was like the correct answers from the AI assistant, I'm guessing? But how does it know that? Start of turn user response part. Oh, okay, I see. So it's like, it's looking inside of like the data set and basically saying, oh, the response part is everything that comes after this. And then like the instruction part is maybe the part just from like the user to ignore, I'm guessing. Okay, so tokenizer train on train data set. So that's this over here. So now let's verify the instruction part is done. Let's print out the 100th row again. So beginning of sentence, start of turn. What is the modulus operator? Oh, I think I was wrong actually, because start of turn model. How the sample has a single BOS as expected. But I thought there was a step where we like remove BOS. BOS. Yeah, we remove BOS, I thought. Input IDs. I'm not quite sure. Now let's print out the masked input. Oh, okay, this is the thing we wanted in programming. Okay, so this was not reflected of our work here. Decode input IDs. Now let's print out the masked example. Tokenizer.decode pad token if x equals minus 100 else x for x and trainer data set variables replace. Yeah, I don't know. I'm sort of lost here. But it looks like it's working, which is cool. Show current memory status. Max memory. Oh, okay, that shows us how we are. Now let's train the model. To resume training, run set trainer, resume from checkpoint. So I guess we're just using this new modified dataset, I think, to only train on the system outputs. Or now we're just focusing on the system outputs to train, I guess. By the way, we are at the 30 mark here. I don't think I'll be an expert at this at the end, but this is actually pretty interesting and fun to learn about this stuff. Did I miss a step? Okay. Okay, so let's run all. So now we're just running all of them in sequence here. Yeah, it looks like we ran into an error here. Expected at 1 and at 2 to have the same D type. I think with here, we learned a couple cool things, but here I'm gonna try a different notebook. I'm gonna try maybe a smaller one. Gemma 4B. That's the one I tried though. Let me try 3.2. And then we're just gonna hit run. Run all. Okay, why don't we get rid of 4B? And try this again. And let's hit run all. And let's see if these are not managed sessions. Okay. Let me try this one now and just hit run time, run all. Oh. Did I click on the right one? Yeah, I guess I clicked on Llama 3.2. So here, let's see if it's doing the same thing. Installing Unsloth. it's getting importing fast language model instead of fast model. And then 4-bit pre-quantized models we support for 4 times faster downloading. Our adapter, looks like we had lower adapters here. And then we're using the same data set. We converted to Hugging Face's normal multi-turn, begin of text instead of beginning of sentence. We use get chat template here. So we're getting the same, we're like retrieving a template. So we now use standardized share GPT here. So we change it. This changes the data set from human to role content. Okay. Now we look at the data set conversations, then text. It doesn't look like we remove beginning of text, do we? And now we're training the model. So it looks like after this, we can do train on completions. So I think I'd love to know what's actually happening in training and train on completion. So this always happens after training. So I'm guessing this is something that can only be done after we do this step. So in chat templates, we train on response only, which we saw last time. We start on the header ID. So this is the instruction part. And this is the part that we're going to extract. So we focus on the AI responses only, or the assistant responses. And then we verify if the masking's done, which I think like this decode part will actually still show this one, but this part will actually show the sort of like interpolated part as well. I think we're almost done here. Okay, so this still has the beginning of the text, and then this is the part that's cut off. And now I think they're doing the final training. So this is the part where, like last time, we got the error on like the Google Gemma model. You know, if we zoom out, what is this one really trying to train it to do? Is so we're installing it. So we're like converting it to sort of change its conversation style, I think is the takeaway. So what I'm sort of seeing is like we give it a data set, we change, like we modify like the data set to match like a chat template, or we convert it into like a different format. We then create that as the new sort of like modified data set matching that new like format. And then we have the model sort of like train on it in the first step. And then we get only the responses of like the output, and then we train it again. Sort of what I'm understanding. And training loss, I'm not too familiar what this is. Inference, I sort of understand. Sort of my bread and butter. And then, it's pretty great. I guess maybe this is the whole point, is that it's not necessarily conversational. From system, role, content, yarn assistant. I wonder if I'll pause this part until like it loads again. Yeah, I think I might pause this part Okay, it looks like it's almost done here. And then, okay, cool. Step 1, step 2, step 3. I guess I'd have to learn the significance of these steps here. Okay. 400 seconds used for training, 6.7 minutes used for training. I think that's pretty impressive. Let's run the model. Okay, I don't know if this worked actually. Oh wait, I think it worked. Continue the Fibonacci sequence. Series of numbers. Cool. And then here we can say, tell me something cool about SF. Okay, so this is its cutoff date. And SF is a fascinating genre. Not exactly what I meant, but sure. And it looks like here we can also use this for continual inference. Yeah, this is pretty good. I think this is a pretty good place to stop. It looks like we trained a model. And it looks like the big aha was we trained a model to sort of work in a different format, aka the role user content right here, rather than in the beginning. It looks like it was more of a system human value user. So this is actually pretty neat. Thanks for watching.